Hi everyone, welcome back. Now I gave you that whole idea of having the specific heat of a solid or an incompressible substance being a constant. And so I want to do a problem with that. So here we go. We have an ordinary egg, okay, and it can be approximated as a 5.5 centimeter diameter sphere. If you see diameter, it's typically telling you an area or a volume. In this case, it's giving me a volume using that. I'm going to put a line through this to let you know that's a capital V. The egg is initially at a uniform temperature of 8 degrees Celsius. And is then dropped into boiling water at 97 degrees Celsius. Take the properties of the egg to be, well, here's a density and here's our specific heat. As a note, I can get rid of this. Determine how much heat is transferred to the egg by the time the average temperature of the egg rises to 70 degrees Celsius. Okay, a lot of information here. Let's go ahead and first draw the egg. There it is. Beautiful. 8 degrees Celsius on the inside to begin with and 97 degrees Celsius on the outside. Now we have to do an energy balance for the egg. So the change in energy in my system is going to be equal to the energy in minus the energy out. Now, since it's hotter on the outside than the inside, I'm just going to have energy going in to my egg. So my energy out is going to be equal to 0. My energy in is going to be equal to the heat in. And the heat in is going to be equal to the change in energy of my system, which is the change in the internal energy of the egg, which comes out to be my mass times my specific heat times the change in temperature. Okay, I have a specific heat, I have a change in temperature, I don't have a mass. So I need to calculate that. Now it gave me a diameter, and I can use that to calculate the mass of the egg. So mass is equal to density times volume. If you wonder where that came from, remember that density is equal to mass over volume, probably more familiar with that, and I just rearranged it. So I was given a density. This right here is the equation for the volume of a sphere with diameter. So volume of a sphere, there's two ways you can do it. It's equal to 4/3 pi r cubed. It's also equal to pi diameter cubed over 6. So depending on what you have. And do notice that I went ahead and I converted from centimeters to meters. I had to do that because this was in meters. I needed this to be in meters as well. So when I do that, I get a mass of 0.0899 kilograms. And now I can finally solve for how much energy went into this egg. So it's going to be equal to my mass times my specific heat times this change in temperature, which comes out to be 18.29 kilojoules. Now, if you're wondering why I didn't convert this to Kelvin, it's because a change in temperature in degrees Celsius is equal to a change in temperature in in Kelvin. If you want to check that, you can do it pretty easily. So I'm going to have a change in temperature of 100 degrees Celsius. I'm going from 0 to 100 degrees Celsius. And so 0 degrees Celsius is 273 Kelvin. 100 degrees Celsius is 373 Kelvin. So now let's take the change in temperature in Kelvin. And that's going to be equal to, really run out of room here, 373 minus 273, which is simply equal to 100. It's the same exact value. Okay, so we got our problem done. Hopefully this helps you, and I'll see you all next time. Bye-bye.